Today, we explore those leviathans of the ocean capable of carrying over 24,000 containers on a single ship. How do giants like the Ever Alot, the CMA CGM Jacques Saadé, or the latest 24,000 TEU monsters built for MSC transport masses exceeding 240,000 tons without cracking under pressure of the waves? How do their engines, among the most powerful ever conceived by humanity, propel these floating skyscrapers while trying not to anger the planet too much? And finally, what hydrodynamic and structural innovations enable this race for gigantism without these ships ending up scraping their paint in the Suez Canal? The answers are in this video. Let's go! At the heart of this excess stands the Ever Alot, the flagship vessel of the Taiwanese shipping company Evergreen's A-Class. Commissioned in 2022, it was the first to cross the psychological barrier of 24,000 TEU, 20-foot equivalent unit. For those in the know, it can carry 24,004 standard containers. That's a lot of sneakers, television, and smartphones. If you've lined up all these containers on the ground, you'd have an uninterrupted line 145 kilometers long. At 399.99 meters in length, because 400 meters was probably too intimidating for port authorities and insurance companies, and 61.5 meters wide, it flirts with the physical limits of the Suez Canal. Its draft of 17 meters means it carries the equivalent of a 6-story building underwater, forcing ports to dredge their sunbeds or risk the giant running aground at the first turn. With a deadweight tonnage of 240,000 tons including cargo, fuel, and supplies, the total height of the container stacks often exceed 30 meters above the deck. At this point, we're no longer talking about a ship, but a fortified city that decided to take an extended vacation on the high seas. These spectacular dimensions aren't due to some superiority complex of the ship owners, but a quest for relentless mathematical optimization. Ultra-large container vessels, ULCVs, like the Ever Alot or the new MSC units built by Hudong Zhonghua, share similar genes. They're all about 400 meters long, because beyond that, turning in ports becomes, let's say, athletic. The hulls are sculpted by supercomputers using fluid dynamics to reduce drag. They feature optimized bulbous bows, those famous rounded noses at the front that create an artificial wave to cancel out the ship's own. Some units are even testing air lubrication, creating a carpet of microbubbles under the hull so the ship glides over the water like a bar of soap in a bathtub. It's technical, it's clever, and it allows for gaining a few precious points of energy efficiency, turning every drop of fuel into extra kilometers. They also study the shape of propellers over 10 meters in diameter, each blade weighing several tons to avoid cavitation. A phenomenon where water literally boils due to the rotation speed, which would eventually eat away at the steel as if a school of piranhas were attacking the ship. But hull engineering is the true hidden challenge of this industry. On this scale, a ship is nothing but an immense metal beam subjected to the ocean's changing and sometimes brutal moods. Imagine the structural stress when the bow and stern are lifted by 2 wave crests while the middle of the ship, loaded with thousands of tons of cargo, finds itself in a trough. This is called hogging and sagging. In those moments, the steel must be able to flex without breaking. To prevent the ship from bending in half like a cheap straw, engineers use high-strength steels and stiffeners dimensioned to the millimeter, capable of absorbing colossal stresses. This is also why these ships can't be lengthened indefinitely. At some point, physics wins and the steel finally says stop. Each additional meter would require such reinforcement that the ship would become too heavy to be profitable. The ship is actually an assembly of thousands of blocks welded with surgical precision because a single faulty weld in the middle of North Atlantic could turn this technological flagship into a premature artificial reef. Below deck, we leave the world of poetry for that of brute force. The propulsion of the Ever A class relies on monumental two-stroke diesel engines from the MAN B&W G95 family. We're talking about a power of around 60 megawatts, or more than 80,000 horsepower. For perspective, that's the equivalent power of 500 luxury sports cars, but with a rotation speed of less than 80 revolutions per minute. The pistons have a bore of 95 centimeters. These engines drive a single propeller without a gearbox. Nowadays, the trend is slow steaming, sailing between 18 and 20 knots to save fuel and ease the strain on the engines. It's a bit like driving a 40-ton truck at 70 kilometers per hour on the highway. It's less fun, but your wallet and the polar bears will thank you at the end of the month. They also install scrubbers, giant exhaust gas cleaning systems that take an enormous amount of space in the funnel to filter out sulfur and prevent turning the ship's wake into a toxic cloud. For those wanting to go greener, the CMA CGM Jacques Saadé led the way with liquefied natural gas, LNG. This 23,000 TEU giant carries 18,600 cubic meters of gas maintained at -161 degrees Celsius in a colossal cryogenic tank. Its dual-fuel WinGD X92DF engine is a little gem capable of burning gas or conventional fuel oil. Switching to LNG reduces CO2 emissions by 20% and virtually eliminates sulfur oxides. It's a big step forward, even if installing this tank in the middle of the ship is like trying to fit a gigantic, unbreakable thermos into an already full travel bag. It requires a total reorganization of the ship's internal architecture from the design stage. Crews also need to be trained to handle this explosive fuel, adding a layer of complexity to the already busy lives of the sailors. The future will likely involve ammonia or green methanol, but for now, LNG's the champion of the sea's heavyweights. Beyond brute force, these ships are floating digital brains. Loading 24,000 containers isn't done randomly or based on the crane operator's mood. It's a global logistical headache managed by the ultra-powerful software. You have to balance the masses, account for the center of gravity to prevent the ship from listing dangerously, and most importantly, ensure the container needed at the next port isn't buried under 10 other 20-ton boxes. On the bridge, officers no longer just look at the horizon with binoculars. They have tools that cross-reference satellite weather data and real-time consumption to adjust the route on the fly. Everything is optimized, down to the last liter of fuel, transforming these monsters into logistics platforms of surgical precision. Sensors are everywhere, from the engine to the hull, monitoring for the slightest abnormal vibration that could herald a costly breakdown. Satellite connectivity even allows for remote diagnosis of a problem from the shipping company's headquarters in Marseille or Taipei while the ship is lost in the middle of the Indian Ocean. Finally, the birth of these titans is an industrial feat that takes place in monumental shipyards, primarily in South Korea and China. You don't build a ship, you assemble giant puzzles. The hull is divided into dozens of pre-outfitted blocks, some weighing several hundred tons, welded together in tri-docks so large you could fit 2 football stadiums inside. It takes about 18 months to bring one of these giants to life, from the cutting of the first steel plate to sea trials. Everything is checked by classification societies that don't mess around with safety. Every weld, every electrical cable is inspected. Once the engine has roared to life for the first time and the maneuverability tests are validated, the ship leaves its nest to begin a 20-year career crossing the oceans. These engineering records prove that humanity is decidedly not afraid of excess as long as there's goods to be shipped from one end of the globe to the other. That concludes this deep dive. Thank you for following along till the end. If you enjoyed this video, feel free to leave a like and tell us your opinion on these giants in the comments. New episodes are coming soon, so don't forget to subscribe to the channel and hit the bell icon to miss nothing. See you very soon.